Hello everybody, how are you all doing? My name is Dylan Beattie, and I do interesting things with computers. I'm the founder of Ursatile, which is my online training company. I'm a Microsoft MVP. I run the London.NET user group, and I once created a programming language as a joke that was so successful that it became a joke with a reference implementation and a test suite. It is the programming language called Rockstar, and we are going to hear a little bit about that over the course of the talk today. Now, I'm one of those people who loves making things. Lego, woodwork, cardboard models. My dad got a computer when I was about 7 years old, and I spent a few weeks figuring out how to run games on it, and realized pretty quickly that I didn't want to play other people's games. I wanted to make my own games. And that was the start of my long and illustrious relationship with the craft of software development. Now, I use the word craft there. That's something that's had a lot of attention over the last decade or so. You know, there's this long, fascinating discussion about what is it that we developers actually do. You know, coding, is it an art? Is it a science? Is it engineering? Is it an art form? Is it just glorified typing? Is it not glorified typing? Well, I think code can actually be all of these things. It depends on the code. If you've ever had to write functions that do things like calculating tax codes, it's basically data entry. You got a big list of rules and numbers over here, and you just need to translate those rules into C# or Java or something. I've written code that definitely felt like engineering, code where we were analyzing failure thresholds and metrics and monitoring, looking for bottlenecks, just as if we were creating a physical component to go in some kind of machine. I've written code just because I wanted to see what it did, and then thrown it away as soon as I'd answered the question. I didn't actually throw it away. It's probably on GitHub somewhere, but good luck figuring out what it does. But I've also written a lot of code just because I wanted it to exist, because I love the idea of computer programs that are also poems or songs or jokes. One of my favorite code snippets ever is this one. This is the C# lunch order. It's your public class lunch order, double cheeseburger, char grilled peppers, shortcake, Long Island iced tea. I also like this one. This is a poem, a joke, a cultural reference, and it's a valid class in C#. It is public class Muhammad Ali, float like a butterfly, string like a bee. But let's go back to the idea of software as a craft. Now, the language here you might find it a little clunky. You see, English is a dreadfully gendered language, and we have these words like craftsmanship and workmanship, and we have people who insist that those terms are inclusive, and the people doing the insisting tend to be men, so maybe we don't have an entirely balanced perspective here. So I'm going to talk about craft, and I'm going to talk about crafting, and I'm going to talk about Craftship. And I think most developers agree that there is an element of craft in the way that we write code. Variable names, indentation styles, little signs that the person who wrote the code, they don't make any difference to the computer. The compiler, it means exactly the same thing, but they tell you when you read that code, the person who wrote this, they cared, they were paying attention. And, it's natural for us to assume that if somebody paid attention to the little things and got those right, they probably also paid attention to the big things, and they got those right as well. Now, the comparison here, obviously, is with people who craft physical objects. Now, I'm a guitar nerd. I love guitars. I own many, I've built a few myself over the years, and the craft of guitar building is called luthiery. And when you pick up a guitar, there are countless little details that can tell you what kind of luthier built that guitar. You can walk into a store today and buy a pretty good guitar for about $200 or $300, but if you look closely, you'll notice little details, screws that maybe don't quite line up with the holes that have been drilled for them. You get tiny gaps between components that are supposed to fit perfectly flush. Maybe the odd flaw in the varnish here and there. But if you go out and spend $10,000 on a guitar, you expect perfection. You're expecting, a high-quality product crafted by an artisan who knows exactly what they're doing, and they have the skill and the time and the resources to create something that literally, they couldn't have made that any better. And let me tell you why this idea of, software craft, why I find this idea interesting and perhaps a little odd. And it's down to one thing. In software, we have revision control. If you're building a guitar, and you make a mistake, you have a problem. If you drill a hole in the wrong place, you can't undo it. You need to fill it and then drill it in the right place and hope you get it right this time. If you're cutting timber, if you cut a piece of wood slightly too big, yeah, it's all right. You can sand a little bit off the end. If you cut a piece of wood too small, there's no way back from that. You have to throw it out and hope you have another one. And, we could be talking about figured maple or, tropical mahogany here. Single piece of wood could cost hundreds of dollars. And maybe you didn't even make a mistake. Maybe you just changed your mind. Maybe you just finished staining your latest guitar cherry apple red, and now you're just really wishing you'd gone for midnight blue, but tough. The guitar is red, and it's staying red, unless you want to spend a couple of days sanding it back and refinishing it. And if you accidentally run over your guitar with your car, there are no backups here in the real world, my friends. You are in the market for a new one, which most of us are anyway, let's face it. But in software, it's very easy for us to create a working environment where almost every decision that we make is reversible. You press the wrong key, no big deal, backspace. You decide that you really don't like the method you just wrote, undo it. You realize you just spent the entire day building the wrong thing because the product owner forgot to mention that the data export is going to be XML and not CSV. No big deal. I mean, you get a little bit upset, but you can roll back. You can go back to an earlier commit, delete the files, fill in some new ones, and if you accidentally wipe your entire hard drive and lose all of your work, we have backups, right? You have backups, GitHub, Dropbox, iCloud, maybe just email box full of zip files. A couple of folks out there probably suddenly looking a little bit nervous. Go on, take a moment, back stuff up. I won't mind. But imagine for a second that writing software was like building guitars. You can't use backspace, you can't use undo, no revision control, no backups. Every single thing you do, every action, every decision is permanent. And if you go to compile your solution and there is a bug in one of your files, maybe the file gets completely corrupted and you need to write it again from memory. That doesn't sound like a whole lot of fun, does it? Now, I bring up the comparison for two reasons. Partly because I think it's interesting, and I like to remind myself and maybe remind all of us working in tech with our backspace keys and our undo and our rollback strategies. It's worth remembering we actually have a pretty good time of it. But I also brought it up because it establishes to me too extensive a spectrum. And at one extent of this spectrum is a completely digital, non-destructive workflow where if we have enough hard drive space, we can keep every single version of every single element of our projects. Every decision is reversible. And at the other end, we are building guitars from limited stock Honduras mahogany, and if we make a mistake, you've blown the whole project and you're maybe thousands of dollars out of pocket. And within my own lifetime, there are art forms, media, there's entire industries that have moved from one end of the spectrum to the other. 30 years ago, making a movie was a bit like making a guitar. Movies were shot on film. That's where the word footage comes from. Film stock was sold by the foot. And so every minute of your movie would take about 90 feet of film. So you have to figure out how many feet of footage you needed before you go and shoot on location. And after a couple of weeks shooting, you'd have all these canisters of film. No backup copies, just a few thousand feet of 35mm film stock. And editing a movie was a destructive process. You'd find the scene you want, you would slice the film with a blade and attach it to the end of the previous shot with adhesive tape. It was incredibly delicate, painstaking work, and that's how they made Citizen Kane and Gone with the Wind and Star Wars and Ghostbusters. And today, there are some directors who still insist on shooting on film, but even then, the film is normally then digitized before they start editing. The vast majority of film and TV production has moved all the way across this spectrum. It is shot on digital, it's imported into tools like Avid and Premiere. The entire process is non-linear and non-destructive. And, music is much the same. A $1,000 MacBook today has more editing power than the whole of Abbey Road Studio did in the 1970s. And that gives us freedom. It gives us the ability to try things out, experiment with ideas and effects, and if you don't like it, hey, no big deal. You can just roll back. It's wonderful. And when you're learning, that ability to explore and experiment is fantastic. And the thing about working across all these different kinds of media, from wood and metal to music and video and computer code, is, I'm always looking at tools that exist in one of those domains and wondering what it would take to use that tool somewhere else. And I don't just mean wanting to be able to debug source code with a hammer, even if we all have days like that. Now, early on in my career, I used the same revision control strategy for everything digital. I took a lot of copies. I'd copy stuff to floppy disks and then to CD-ROMs and make backups before I did anything that might turn out to be a bad idea. And this worked for, source code, photos, music, basically all the stuff you could do on a computer in the late 1990s. When I started working as a professional developer in the 2000s, that didn't really cut it anymore. Now, this is 5 years before Git was invented, so when it came to revision control, we had a couple of choices. We had CVS. I had to learn CVS at university. The only thing I really learned in that course was that I did not like CVS and I did not want to use it anymore. There was Microsoft Visual SourceSafe. Any of you remember SourceSafe? The way SourceSafe, it couldn't really cope with merge conflicts, so it avoided them by ensuring that only one person at a time could edit a file. To edit a file, you had to check it out, and no one else could work on it while you checked it out. So you'd check the file out, you'd make your changes, you'd check it back in again, and that sort of worked up to a point if you were all in the office together and you're all on the LAN, and if somebody forgets to check a file back in, you can just shout, "Oi, check your file in" at them across the room, Then they invented laptops. And some bright spark goes, "Ooh, I'm going on a business trip. I better check out all the project files in case I need to do any coding on the plane," and boom, nobody else can do any work at all, because Nigel has checked out the entire project and Nigel is somewhere on an aeroplane. Now, there were some commercial solutions. There was BitKeeper, I think Perforce was another one. And these were, pretty good, I gather. Some guy called Linus apparently used one of them for his open source operating system. But they were expensive. And, I was an undergraduate and then I was working for a .com startup, except without the budget you'd normally get. We couldn't afford things like, BitKeeper. But we had Subversion. And I loved Subversion. I set up Subversion every place I worked and had projects running on it for years. And, for me and for a lot of other developers of a certain generation, Subversion was where we encountered concepts like branches and merges and tags, these kinds of ideas. It was a completely new model of collaboration. And I used Subversion along with a thing called Tortoise SVN, which was the Windows GUI for it. I used that as my main revision control system for many, many years. And it was brilliant. There were really only two significant drawbacks. First of all, every once in a while with Subversion you get something called a tree conflict, which is where one of your branches had diverged so far from the trunk that Subversion could no longer work out kind of how to put them back together. And that got a bit convoluted. The other occasional frustration with Subversion was that it had this bizarre insistence that history had to happen in chronological order. And, well, it turns out rewriting history is actually pretty useful. Every couple of years, an American tourist will be driving around the part of England known as the West Country. And if you're not familiar with the West Country, it's basically Hobbiton from the Lord of the Rings movies. It's where all the hobbits' accents came from. It looks like the Shire. It's a lovely part of the world. And our tourist will be trying to find their holiday accommodation, which will be a cottage in a field on a farm somewhere that Google Maps has never heard of. And they'll pull the car over and they'll say to one of the locals, "Say, excuse me, do y'all know the way to a Hot Pocket Farm?" And the local gives him a funny look and is like, "Oh, well, I wouldn't start from here." It turns out in software, that actually happens quite a lot. Software development is a process of discovery, which means by the time we've finished implementing something, we've often learned a whole bunch of stuff that we wish we'd had when we started. You ever get the thing where you're halfway through adding a feature and you suddenly think, "I should have refactored the data access layer before I did this"? And it's that sold me on Git. Time travel, or rather the freedom to make changes across multiple branches and then apply those changes in the order that makes sense. Now, at the start of this talk, I mentioned the Rockstar programming language. And when the organizers invited me to speak here at Git Con, one of the questions they asked is, whether Rockstar does anything particularly interesting with Git. And I sort of thought about this. I'm like, well, not really. It's a quirky, esoteric language where all of your programs are also heavy metal songs. So it lets you write code that is also lyrics, song lyrics, 80s heavy metal bad power ballad song lyrics. So the language itself is kind of weird, but the code base is it's a JavaScript project with a bunch of documentation in Markdown format. And then I thought actually there is something that Rockstar does which is a little bit unusual, something I've not really seen anywhere else. Now, Rockstar is actually two repositories. They're both on GitHub, they're both open source. There is the core Rockstar language repository. That includes the language spec, the interpreter, the test suite. And then there's the website, codewithrockstar.com. And that site is built using Jekyll and GitHub Pages, and I wanted a way. The website is basically like the shiny public version of the language spec, plus a couple of other things. So I wanted a way to maintain a single definitive spec and have it appear in multiple places as part of the language repo and as part of the project website. Now, I didn't want to turn the Rockstar language repo into a GitHub Pages site, because that would mean that the language spec and the compiler would end up as subfolders of a website, which kind of felt like getting it the wrong way around, you know. And GitHub also has a thing where you can take your /docs folder, and I think any folder, and you can say that's the website. But if you do that, there's no way of pulling in stuff from outside the docs folder and making that part of the Jekyll site that's going to get published. And I didn't want to get into, publishing NPM packages or anything like that, but I had an idea, what if I could use submodules to import one repository into another? Submodules, I think, don't get nearly enough love in the Git ecosystem. They are an incredibly powerful pattern for a specific code reuse scenario. And that's what I did. The Rockstar website repo imports the Rockstar main language repo via a Git submodule, which means all of the language spec files are available as part of the source tree that I use to build the website. So I can pull in snippets, chunks of the language spec, and JavaScript components and stuff straight out of the language repo and put them on the main website. Now that works really well. But it occurred to me while I was putting this talk together that actually there might be another way that I could have done it, which would be to do it using branches. Now, I realize long-lived branches are kind of controversial. There's people who will keep a feature branch open for a couple of months at a time, and there's people who think feature branches should only exist for a couple of hours, and there are people who think you shouldn't have any branches at all because all branches are bad. I'm kind of open-minded about the whole thing, but I do have a scenario at the moment where I'm using Git branches in a fairly unusual way. I teach a lot of coding workshops, 2 days or hands-on, coding, building distributed systems or JavaScript components, and I've written code for all kinds of applications in my life. Production code, prototypes, experiments, jokes about lunch orders and Muhammad Ali quotes, but I think the most difficult code bases I've ever maintained are the examples I use for teaching. For starters, you've got to be able to explain, prepared to explain and justify every single line. And yeah, I know that is how all code should be written, but I'm sure I'm not the only one here who has occasionally copied and pasted something from Stack Overflow, and it works, and you're not quite sure why it works, but the tests are all green, and it's late, so you ship it to production and you go home, and don't ever really get around to understanding what it does. It's all right, we've all done it. I won't tell your boss. Second, workshop code, it ideally has to run on machines you've never seen before. Somebody turns up to one of my workshops with a Chromebook that they've somehow hacked to get the .NET runtime onto. I mean, they probably know what they're doing, and technically I could say that's not supported, but we all have a much better time if I can get that code to run. So I tested on a whole bunch of different platforms and things, but the main reason why workshop code is challenging is that it doesn't, you don't have like a release version. It has to exist in multiple states at once. In each of my workshop repositories, there are half a dozen branches that represent the state of the code at a particular point over the course of a 2-day workshop. If you saw the Loki series that was on Disney Plus earlier this year, you've got people jumping around on different timelines and rewriting history and trying to get everything to line up. Maintaining workshop code feels a little bit like that. In my head, I kind of picture 2 days of workshop as all these little moments from history stretched out side by side like Loki's timelines, because if I need to update a reference or fix a bug, I can't just fix the final version of the project. I need to think about at what points in the narrative, the story that takes place over those 2 days, where does that fix make sense? Where is it relevant? And so each of those branches, they're not feature branches that are ever going to get merged back in. Each of them is a long-lived window onto the latest version of a possible future as to how that code base can evolve and develop over the course of the workshop. And That it took a little while to figure out, but it works really well. And I honestly believe that without Git, it wouldn't even have occurred to me to try, let alone, figure out a way to do it. I find that a lot with Git. Like a lot of very powerful tools and techniques, it doesn't just give you a new way to do things. It gives you a new way to think about things. And until you've grokked the concepts that are involved, trying to explain them can come across as a bit meaningless. First time someone tried to explain to me what a rebase was, it didn't make a lot of sense. It was like, so we end up in the same place, but it looks like we got here from somewhere else. And I'm like, yeah, and it's like, this is like tourists getting directions in Somerset all over again. But in GitHub, it works. In Git, it works. It took me a long while to figure out, and it finally clicked. And it's not a feature I use very often, but on the occasions that I do, I often find myself wondering, how we ever wrote code without it. Now, I want to wrap up today with something a little bit different. Some of you may remember back in 2016, the folks at Axosoft, who've helped put this whole event together, they were about to ship version 1 of Git Kraken, which is a product that I use daily and I love it dearly. It's fantastic. And they had a songwriting competition. And I entered it and I didn't win. And that's okay, because the song that I wrote was not very good. At one point, I think I rhymed Git Kraken with Get Snackin'. The song is still floating around on SoundCloud if anyone wants to hear it. But at the time, I had another idea kind of in the back of my head. An idea for a piece of music that evolved based on branches and merging and rebasing and, all these ideas. What would a merge conflict sound like if you interpreted that through music? And that idea kind of bubbled away for years, and it would pop up once in a while. I'd play around with it and I'd put it away. And then when Dwayne emailed me to say that they were putting together Git Con and would I be interested in speaking, I thought, maybe it's time to see if I can turn this into something. And so here it is. It's a completely new piece of music inspired by Git. Now, remember, folks, this is art. Git does not let you branch and merge tracks in a piece of music the way that I've portrayed it here. So you do not need to email me and tell me that you tried it and it didn't work. If you try it and it did work, definitely email me, because I would love to know how you did that. And if anyone out there is working on revision control for woodwork and guitar projects, get in touch. I'd love to hear about how you did that. But in the meantime, folks, thank you so much for watching. I'm Dylan Beattie. You can find me online at dylanbeattie.net. And this is, I guess you could say, it's a song about commitment. It's inspired by Git. It's called Rebase. I hope you enjoy it.
Wow. I am so glad that we got to do the world premiere of that. That is amazing.
Thank you very much. That was a lot of fun putting together. How you all doing?
Awesome. Thanks so much for being here, Dylan. Thanks for that amazing talk. I mean, the end got us all wowed, but the whole talk was amazing. Thank you so much.
So I always, when people invite me to do talks, I'm like, I use Git a lot, but I am by no means one of the world's foremost experts on it. And I always try and come up with a talk that nobody else could do. Because I think if everyone on a program does that, then you get a really kind of good balance of perspectives and experience and all that. And let's face it, when Ed Thompson is on the bill, there's no way I'm going to say anything about Git that Ed doesn't know 100 times better than I do. But so I'm like, yeah, great. And then literally the idea for that was 2016. It was the Git Kraken 1.0 songwriting battle. And I had this idea in my head of, I wonder if you could rebase a piece of music, and it all kind of grew out of that, and it's just bubbled around for a couple of years, and 5 years, and now it's done, and it's a thing, and the rest of the world can see it on YouTube in about 10 minutes. So, but you got to see it first.
Absolutely. All right, let's dive into the question. We've got a bunch of questions here. How do you feel about submodules versus package managers? Asked by Alexi out there on Discord.
They solve different problems. To me, I have done stuff before where a classic example of this is you have like a set of shared types that you're using like for a publisher and a subscriber in a messaging system. So you've got separate code bases that need to share some small snippet of code, like a couple of little classes or something. And I've worked before in projects where we did that by using an internal package manager repo. And like you'd be working away on something, you're like, oh, I need to update the message format. All right, let me stop what I'm doing, check out that repo, make one change to something, open a PR, get it reviewed, get it merged in, get that pushed through the build pipeline, wait for the package to appear on the feed, and then go back into what I was doing before and install the updated version of the package. And what happens very, very quickly is everybody stops doing that because it's such a laborious workflow. And so everyone kind of has their own local copy, and they've changed the project references to reference that kind of stuff. If you are sharing code with people who you've never met and you're publishing it on the internet for other people to consume, package managers are great. If you want to manage code that is shared between multiple projects that you control and which is never going to be consumed by anybody else in that format, I think submodules is a fairly compelling solution to doing that. It is, as we sort of mentioned in the Discord, if you're using submodules of someone else's repo, that is a supply chain attack waiting to happen, because you are literally getting, I mean, we all clone code off GitHub and run it and pretend it's going to be fine all the time. So, depending how rigorous your InfoSec policy is. But yeah, submodules is potentially a way that code you've never seen before ends up in your build pipeline and then goes public on one of your projects. So you need to be very careful that you control, both parts of the pipe. But yeah, I use them both. I do stuff with package managers. I do stuff with submodules, and I have some specific scenarios that without submodules would be effectively impossible. So yeah, that's my thoughts.
Definitely some good insight there. It's amazing how much of our modern life, not just with code, is controlled by security policy. So,
well, I did a talk at Deutsche Telekom Security earlier this week about that, and one of the things I said is, the problem with computers is the more useful they are, the less secure they are. What we want is, you unlock with a thumbprint or just by smiling, you get on the Wi-Fi and you go and share your stuff. And that's what makes them useful. That's what makes them fun. And that's what makes them cool. And that's what makes them so tempting for people who are trying to, compromise information. And creating a pit of success for security is a real challenge. Fingerprint readers is I think a great step forward, although I do know a friend whose girlfriend got him drunk on tequila and then used his unconscious thumb to unlock his phone, found out he was cheating. So it's not, biometric is not all it's cracked up to be. But
can't feel too bad for him.
Yeah.
You mentioned it there. You're doing multiple conferences. You came right off of another conference talk to come right into this conference.
Yeah, I beamed into Romania this afternoon to do Code Camp with the .NET over there. And it's one of the fun things about stuff being online is, you can say yes to lots of different things. And obviously, the style of engagement is it's very different. If we did Git Con in person, I'd be in, where would it be? Arizona somewhere right now? and there'd be a whole bunch of people who were out there for a couple of days, and we'd have found the cocktail bar and the karaoke bar and the good coffee place, and you get a sort of very different kind of engagement, but it also means you can't do anything else while you're doing that. And there's always the few unfortunate people who have a work crisis while they're at an event, and they spend the whole thing chained to a laptop trying to fix a production issue that no one else can figure out. I'm growing to like both. Now that there's some in-person events coming back, I enjoy the contrast between the online stuff and the physical stuff. When it was locked down and everything was online, that was kind of hard for an extrovert like me. So
I know that feeling very well. Let's move on to the next question from the Discord out there. Phobos Demos asked, did you consider using tags for your workshop code instead of branches? If so, what made you decide on branches?
I decided on branches because once you've tagged something, you can't change what's in the tag. You have to delete it and recreate it. And the point about the workshop code is that if I, they release an update to one of the packages that I'm using, and I need to make sure that update has been applied, but I kind of need to apply that at multiple points in in the timeline of the workshop, if you like, from the starting point to the... So I have one where I start with a website, and then there's a branch which has a REST API, there's a branch which has PubSub, there's a branch which has a gRPC implementation, there's a branch with SignalR, and then there's a branch which kind of merges all those things back together at the end. And once you've tagged something, it's like, oh no, well now the tag is done this. The tag is intended as a permanent... it's my understanding anyway, and certainly my experimentation has borne this out, is that a tag is a permanent point to that state of that code at that point in time. Whereas what I want to be able to do is to rewrite multiple parallel timelines, but have kind of all of them be new versions of past events, if that makes any sense. The non-linearity gets a little bit clunky when you try to describe it. But yeah, the point about branches is you can keep changing them. Whereas a tag is a snapshot. Once it's tagged, you can delete it and you can make another one, but you can't just go in and go, I'll push this to that tag, push that to that tag. And so that's why branches is the way I approached it.
Absolutely. That is one of the hardest concepts after you understand that everything is local. Like it says on the front of the Git SEM website, once you that's a really hard concept. Once you understand that, the next hardest concept is branching. I always talk about it as parallel universes or parallel timelines. It's our brain function like that in normal day to day.
The Loki series, Phobos Demos just said in the chat, it's fine, I watched Loki too. Yeah, like that you watch that Loki show where they got all the different timelines and they're like, this one branches with that one and this doesn't end there and that kind of stuff. It kind of feels like that. It's
enjoyable watching it, not sometimes living through it to see where did my code go? Where did that?
There's a theory that a Git was actually created in the future and it was sent back in time to Linus Torvalds to prepare humanity for time travel so we can discuss nonlinear histories. So, which I quite like.
And still no one showed up to Stephen Hawking's Time Travelers Convention.
He got the date wrong.
That's it. He got the math wrong, yes.
Yeah, he didn't anticipate that in the future they're going to need to qualify which of the generations of humankind he was referring to.
Moving on to David I99 out on Discord asks, definitely seems like MIDI programming could use Git.
Yes and no. The biggest obstacle to using Git for things which are not text or code is the ability to look at two files side by side and visually interpret the difference between them. And there are people who can read MIDI files the way there are, musicians who can read sheet music and, almost as fluently as most of us can read, written English and stuff. But if you have two MIDI files side by side and you can see something's changed on one of them, it is very, very difficult visually to look at that and figure out whether that change is going to sound good or whether that change is going to, mess up the timing or, any of the other things the other information which is potentially embedded inside a MIDI file. That's the big challenge with collaborating on things like music and video, is that they exist across time. They have to really kind of figure out what's changed. You have to start and you have to play the thing back and see what it looks like or see what it sounds like. And, Git is very much based on the idea of treating software as a frozen artifact. The code base is a static snapshot of a software system which is currently doing nothing, and so you can take two different versions of that snapshot and you can visually compare them and see what the difference between them. And a lot of the interesting ideas that are coming up around, systems reliability and site reliability engineering are about trying to treat a code base not as a static artifact that then does weird things when you turn it on, but how can you visualize it? Think of the difference between looking at a street map and looking at traffic. And, we are only really starting to scratch the surface when it comes to treating software as traffic instead of as a street map with no cars on it. And so you're like, okay, well, I'll use that to make plans. And then you get stuck in traffic and you're like, well, the traffic wasn't on the map. So how was I to know that I was going to be late? And, that's something I think is very, very, has a lot of interesting implications for helping us to understand and maintain the substantial legacy code bases, which a lot of organizations have now, for teaching and improving, people's understanding of distributed systems. I teach distributed systems workshops, and one of the things is, well, the software, the thing you're seeing may be incorrect now, and it may be correct in a second or two because there may be some eventual consistency. And, that's something a lot of people struggle with, the idea of, well, is the software broken or not? And it's like, well, if it doesn't work within an acceptable time threshold, then you can conclude that it's not functioning as designed. But you can't ping it, and if it doesn't ping you back, you assume that it's down. It's not that kind of a Boolean proposition anymore. So
that's interesting. I've not heard anyone refer to code as traffic, not a map before. But it makes sense that we think of now our machines should be cattle, not pets. Now,
hummus. No. Cattle, not pets doesn't work if your sysadmin is vegan. So
it's true.
Servers should be hummus.
Servers should be. As a vegan myself, I appreciate that sentiment. All right. I was going to ask this later, but you kind of alluded to it when we started answering that last question. How on earth did you make that video? Because that is quite amazing.
So it's made in the music is recorded in Logic, and it's just, I kind of started with the end. I came up with about 10 different instrumental parts that all worked well together. There's a plugin called Isotope, does the vocoder, the Daft Punk style vocal. The guitars are all real guitars. The rest is Logic sounds. And then I took that and I sort of took pieces out of it one by one and worked backwards. And so it was like, all right, so the doom, 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 the kick drum, that can run all the way through. That's kind of your main branch. And then the others, you kind of branch in and off it. So I figured out the structure, and then I wrote a batch file that did the correct series of Git commits to give me the graph in Gitkraken, the shape I wanted. So, and that's actually on GitHub right now. You can go to Dylan Beattie, github.com/DylanBeattie/rebase. And there's a couple of the scripts I used, but also I've replayed the history. So the network graph of that GitHub repo is the same shape as the thing you see in the song video. And that's like, the repo is now part of the art. So I had to write a batch file to get the right shape. And then I had to get the console transcript thing. I had to write a custom format where each line is tagged with the frame numbers that After Effects would use. And if it's like this number hyphen that number, like frame 1 to frame 26, it means I want the typing effect. And if it's just frame 72, it means it just appears like a console response. And then the stuff at the top is all animated by hand. It's all ellipses and curves with, radius edges, and there's a lot of masks and a lot of keyframing animation and stuff going on. And it is, I love that kind of stuff. It's a very nice combination of programming and creativity. And there's some fairly gnarly JavaScript that I actually had to write to help make the video, having figured out what had to happen at which point of which frame and where all that kind of stuff happened. Then you sit and you hit render and you wait for about 90 minutes because here we are in 2021 and computers are still too small and too slow. Fact of my life, ever since I started, I think there's like a thread. Anything takes more than 2 hours, you just give up. You're like, I can't be bothered. And so we have a sort of an upper tolerance. I switched last year from making my videos 1280 to making them all 1920 high def. And 1280, most things I could do in real time. Like you could move something and then hit play and it would play it. 1920 is too big, so now I need a bigger, faster computer that's like 5 times faster than the one I got with a couple of terabytes of memory. So, I'm waiting.
So in the last couple here, not really questions or comments, but would love to hear, just your reply to them. Josie out there on Discord said, writing code to exist. That's awesome. That was an awesome moment.
Yeah, It's there's a lot of code in the world that somebody thought had to exist, and you look at it and you're like, that shouldn't. This company should not have built their own banking system. This company should not have implemented their own cryptographic algorithms. And the opposite extreme of that is code that doesn't do anything and no one ever needs it, but it's nice that it's there. It's whimsy. It's like you write something, and there's a talk I have, which I'm sure many people have seen, which is on GitHub. It's called The Art of Code, where I talk about esoteric languages. And the language Pete, named after Pete Mondrian, where Hello World is a picture because it's a graphical programming language. And so you can print Hello World and hang it on the wall, and people just think you're into impressionist art. I love that. I love the idea of code that is hidden inside something else, and people can look at it and never have any idea what it is that they're looking at. So,
right on. And then one final one, as we're wrapping things up. I use submodules to build end-to-end type systems and TypeScript. It's an amazing tool to share types between the front end and back end without building an SDK. Just love to hear you expound on that a bit.
Yep. Exactly like I was saying earlier, if you've got some code you want to share between your projects, types are a very good one for front end and back end, message types if you're building message bus systems, validation policies. There's this kind of interesting, the principle in software of don't repeat yourself. I've seen that misinterpreted a lot by, people being, well, that means that our entire project needs to be a single monolithic code base so that this one rule we have about tax isn't duplicated anywhere. And that's not really what don't repeat yourself means. It's like, don't make the same decision in two different places. And something like submodules can be a very good way of capturing some logic around things like taxation policies or that kind of thing, where it needs to be consistent everywhere, but it's, something that your modules need to be aware of, but that doesn't mean those modules need to live in the same solution or in the same build process. And so as a way of sharing logic, rules, structures, those kinds of things between systems that you control, then, give me a second. YouTube just got very excited in another window. There we go.
I love when that happens. I love YouTube and their autoplay sometimes when things refresh.
It's the premiere of Rebase going out to the rest of the world. The folks who weren't smart enough to catch it here at Git Con. That's all right. We got another minute and 52 seconds.
Yes. So yeah, actually we're wrapping up right here. This is the end. Is there anything last parting words you want to say to our audience?
Get out, have fun, be creative, write code because you enjoy it. Don't always worry that everything has to be important. Enjoy yourselves.
Awesome. Well, thank you so much, Dylan, for being here. This is just an amazing talk. Thank you so much.
Thank you very much for the opportunity. And thank you for GitKraken. I use it every day and I love it dearly.
Well, awesome, man. Well, thank you so much.